We're going to be looking at some graph shapes next. So on number 7, it says consider the following function, identify the general shape. So what you're looking at here is where your x is and what type of power it has. You'll notice that x is just normal, meaning it's not in the bottom of a fraction, and it is odd. So anytime you have odd powers of x that are not in the bottom of a fraction, you get n shapes. Now, on my choices, the only n shape is this one. The reason it is backwards is because of the negative that's in front of that particular function. Just as a review, a U shape is when you are going to have even powers of x. So any even power of x would give you that first graph. The two pieces, like you're seeing here, is when you have your x on the bottom. So you'll have some number up here, a 1 or some other number. And if they're not neighbors, there will be an odd power on that x. So the difference between what we had versus that is if your x is on the bottom, that produces the two pieces. And then finally, when you get this other particular graph, what that is you have some root of x and the root is actually even. So a square root or a fourth root. It could even be written as a rational power, power of a half, power of a fourth. So any type of even root gives you that other shape. On number 8, they asked me to consider the following function, and they first want me to name the more basic function. So if you look at what they're doing to the x, the fact that they're raising it to the power of 3, that's all they're wanting there. And then based on that, not the original entire function, just based on this basic function, they want to know the shape. So once again, odd powers of x, they produce n shapes like we have here. All right, so we already talked about this being a even power of x here, this being two pieces with your x on the bottom and an odd power. If you get the two pieces like this one, x is on the bottom, but you have an even power. We mentioned this one up here. This is when you've got the even roots, like a square root of x. If you get the S shape, this is when you actually have odd roots. So it'd be like a cube root of x, or it could be written as x to the 1/3. V-shaped, of course, is absolute value, and then this is just a simple line. So it would be some type of y equals mx plus b format. So make sure you know all your different shapes, because we could certainly choose from any of those shapes. On the next one, again, we are considering the function, but we're going to talk about how it is shifted. So starting with the horizontal shift. With the horizontal shift, you're always looking with your x. And if there is a shift, you'll know there will be something in parentheses like this. If you don't see a parentheses with your x, then that indicates there is not a shift. So in this case, there is not a shift. Now, just as a reminder, if there were, so let's say there was an x plus 2 in parentheses like that, it shifts opposite of what you see. So if you were to see a plus 2, that would actually shift to the left by 2. For the next transformation, we talk about stretching or compressing. So we are looking at what we refer to as the A, which is the number in front of your x term. And you can't forget that that involves if there's a number on bottom. So on this particular problem, there is understood to be a 1 on top, and then notice there's that 3 on bottom. And so what we actually say is that A is a third. We don't look at whether it's positive or negative. We're just looking at the numerical part, and if it is less than 1, it causes a compression. And then they're going to want to know what factor, and that's where you put the third. If that number were bigger than 1, then it would cause a stretch. So I always tell my students, look at the absolute value. Don't pay attention to whether it's positive or negative. You're worried about whether it's bigger than 1 or smaller than 1. For the next part, an x-axis reflection, you're also looking at that A term, and that's where you're worried about, is it positive or negative? So if you don't see anything there, there's no x-axis reflection. If there were a negative sign there, then it would actually have an x-axis reflection. On the y-axis reflection, you're looking directly in front of the x, and so we would need the x actually in parentheses, something like this, in order to have a y-axis reflection. So if the x is in parentheses and you see a negative there, that causes the y-axis reflection. Obviously, we don't have that in this case, so that would be a no. And then finally, on the vertical shift, you're looking for some constant that's either added or subtracted to the x. It doesn't have to be to the right. It could be up front. But basically, it's added or subtracted to your x. In this case, when it's added, that's a vertical shift up. If it were subtracted, it would be down. And then, of course, we say it's 4 units. Part 2 of that question wanted us to determine the domain and range. We're not going to ask you for range unless we actually give you the graph, and we're not, so we would only ask you for domain. With domain, we're only worried about square roots or even roots and fractions, and I do see a fraction here, but once again, that denominator is never going to equal 0, so it's not a concern. So in this case, my domain would be all real numbers. Okay, on the next question, operations of functions. Notice we are adding f plus g, and then we're going to substitute in -3. So when you're adding, you're simply going to take their rules and add them together if there are like terms, such as the 6 and the 10, you'll add them together. I went ahead and plugged in my -3 and then added them. It doesn't matter where you do that, but if they do put a number here, you do have to plug it in. So I plugged it in, simplified. Again, be sure you at least show me this. At that point, if you want to get on a calculator, you can, or you can do it by hand. But bottom line, once I plug it in, I ended up with an answer of 22. Make sure when you subtract them that whatever function comes second, you put it in parentheses like this, because that minus sign here has to apply to both terms. So if you forget, you're going to mess up in terms of not applying it to the 10 like you should. And then once again, if they give you a number to plug in, be sure you plug it in. You can get on a calculator here if you want. Simplified, and in that case, I ended up with +8. Step 3 asked us to multiply them. Again, if you want to multiply them first and then plug in, you can. Since they told me to plug in -3, I just thought it would be easier to plug it in and then multiply. So it really doesn't matter when you do it as long as you eventually multiply. And in that case, I ended up with 105. And then finally, f divided by g. So function f is on top, g is on bottom. Plugging in my -3. And then simplifying, and I get 15/7. Now, if we don't give you a value of x to plug in, if we just put a simple x over here instead of a number, then your answer will have an x in it. So like on this first example, when you got to this step here, if I didn't give you an x to plug in, the only other thing you would do is you would go ahead and combine the 6 plus 10 and tell me 16, and then stop. So if you don't have an x to plug in, your answer will have an x in the final form.